Start recording. Well, good afternoon, everyone. Really a pleasure having you here. Well, thank you, Cesar, for being with us today. It's really an honor having you here in our class. It's really wonderful for us that Cesar can join us today. Cesar is a really well recognized worldwide in all the activities he has been making. He has a Bachelor in Science in System Engineering. He has a master degree in automation, control automation. He has a PhD in applied science and more related in the area of artificial intelligence. And well, he has a lot of position, a lot of recognition. He has been a university professor. He has been in many oil and gas companies in different places in the world. He was also the head of research and development previously in Halliburton. He's currently now with Honeywell, and he's the artificial intelligence applications director in there. Honeywell is one of the biggest company all around the world, and so Cesar is working in there, and he has a lot of really big experience in anything of the use of artificial intelligence and some other things. By the way, now that everybody's talking about agents, that is maybe the most widely named area in artificial intelligence nowadays. Cesar was working with that 25 years ago when he was working in his PhD and his master program. He was already just making some kind of architecture and some kind of proposal for using it in oil and gas companies. So certainly he has a lot of recognition there. And again, he has a lot of works made in Middle East, in Mexico, here in the United States, in South America, and some other places all around the world. So certainly he's a wonderful person also. He's a very kind person. So it's really a pleasure having Cesar in here. I know he's very busy, and because of that, we really appreciate that he can take the time for being with us for this course. Well, thank you very much, Cesar. So please, whenever you want, you can.
Thank you, Franklin. Thank you for the kind introduction. And I'm very good friend with Franklin for a long time. He was my professor in university and one of my mentors. So it has been a long-lasting, very good relationship that we have. So, and it's a pleasure to be here. And always like to come back to my teaching, times. So I really enjoy this time. So Franklin invited me and gave me the possibility to talk about any sort of topic, right? We have that luxury to talk about any topic that I like to share. And that's nice because that helped me to really explore the areas that are making noise, are making wave now in the industry, and share that with you. So today I pick one topic that is now kind of the conversation topic of any CEO, any board in the industrial processes, that is physical AI. And this is something that is becoming a reality. It's something that we have been working for a long time now in the industry and in the academia. And it's turning a very interesting application that I'm going to share some with you today. So the idea is that this is the next frontier of intelligent automation. And I want to go beyond. I would say that it's more than intelligent automation, is industrial autonomy, right? And as we have here in the slide deck, the idea is that the Gen AI, the agentic AI, is getting out of the digital world and mastering the physical world now. And we're looking at very interesting application of what is called the physical AI. As Franklin mentioned, I'm the AI Solution Director in Honeywell Process Automation, the industrial branch of Honeywell. And I'm going to show you part of what we're doing. I'm going to show you what the industry as a whole is doing now. So let me start. Okay, you can see my screen, right?
Yes, perfect. We can see it. Perfect.
Okay, so let's start with the motivation, right? So we always, myself, I always start the presentation for my customers, telling that AI, despite that I've been working in AI for my entire professional life, AI is an enabler. It's a technology enabler. It's not an end by itself. but it's a very important one because it has generated an inflection point. We reached the level of maturity in which AI is a game changer. But we don't deliver AI because it's AI. We deliver AI to enable something that is bigger, that is autonomy. And why we want autonomous operation? Why we want to enable autonomy? And everything starts with the challenges in the industry, right? So industry right now has many challenges related to changes in demand, changes in the market, in the regulatory environment, changes in the supply chain. So that put pressure in the bottom line of the company, right? So they need to adapt, they need to be flexible to adapt to a surge in demand or to a downsize in demand. There are markets that are available in one time and the next day are not available anymore because there is a sanction or there is a new tax environment that make the business different. So that volatility make challenging to work and make the CEOs worry about how flexible their companies can adapt to those challenges. And you have many other the risks. You have operational environment as well. You need to maintain your operation safe, performing. You need to maintain your operation sustainable as well. You need to comply with the regulation and with the goals of energy transition. So there are many aspects that are putting pressure in the companies, and these are the regular ones. Then you have some other risks and some other challenges that are related with the digital infrastructure that you have in place in the companies. So for many years, we, myself included, have been working in digitizing the industry, right? And that means that we have been implementing many type of solutions, different applications, different infrastructures that brings solutions, of course, has brought a lot of progress in how we develop the industrial processes, but as well is bringing challenges because now you have a disparate environment with many applications. You have included now cyber risks that weren't there before. Now you need to integrate those different data sources at different systems. You need to integrate them to work together. So there are many challenges with that digital infrastructure. And there are another kind of challenges that these are very interesting and has been popping up in any conversation we have with our customers. That is the challenges related to the workforce. There is a skill gap. That's a reality. There is people that have been working in the industry for many years, 20, 25, 30 years, that is in the way of retirement. And with that, they are taking a wealth of knowledge out of the industry. And now there is a new generation, which you are going to be part of it very soon, that is coming to the industry. Of course, they don't have the experience of these people that is retiring, but at the same time, it's a generation that has a different way to learn, a different way to interact with the system. And that poses challenges as well. How we can get people engaged. And by the way, the process industries are not hot anymore, right? The majority of the new professionals, it's difficult to convince them to come to process industries. They go to other kind of industries. So we need to make the industry appealing, challenging, and we need to adopt technology so they can actually relate better with the system that manage our processes, right? So we have all these challenges, and the way to address these challenges is through autonomy, is embedding the knowledge of these people that is living in the industry, or the cultural knowledge that you have there into the system, automating workflows, integrating the different infrastructure so you can get better performance, safer operations, etc. Right? So those are the motivations. So the idea is that you need to embark in a journey to autonomy. The autonomy is not something that you buy, click, plug and play, right? So it's a journey. Every industry, every company is going to have a different journey, different level of maturity. But the whole idea is using technology, including AI, to move from expertise-based kind of operations, right? They're relying in the expertise of a few experts to go to full autonomous operation, right? And the idea is to, of course, sustain peak performance operation, higher productivity, safer operations, higher operator efficiency, etc. So we have a framework, and you're going to see how this framework is going to evolve in a little bit during the presentation. That is kind of the base for the solution that we are implementing now in our approach to industrial autonomy. And that framework is called, step by step, is called See, Think, Act, and Learn, right? The idea is that all of our solutions are going to be able to capture information from the process, think or validate or model what is happening to try to define a solution to the issue or the problem that is happening, make the decision on how to act, execute the action, and learn from it, right? Once I implement the solution, I learn if the solution was effective or not, right? And that is going to let me learn for the next time that the issue appears. And that can be used in the digital world and can be used in the physical world as well. The whole idea is to have systems that are self-aware, that can take action by itself, that are not waiting for an instruction or a person to tell them what to do. They go and execute, they are proactive, can configure and reconfigure and adapt by itself. And in the case that you have a failure, can self-heal. That means that if I have a sensor that is not working well, I can look for an alternative. If I have a pump that is getting down, I can turn the back up and keep the process performing, right? That's kind of the idea, that's kind of the vision that we have, and this is the framework that we're looking at, right? And that is you translate that framework to a specific technology, has an anchor that is called agentic AI. And the agentic AI is one of the key elements in modern artificial intelligence, in which you have a set of software entities that has the ability to see, think, act, and learn, right? They have the ability to perceive what's happening in the environment, think, model, that reality, make decision, act, and learn from it, right? And there is a lot of literature about AI agents, especially in the last 3-5 years. That has been a hot topic. So everybody's implementing agents. But for the agents to work, you need to capture information from the environment, right? So you need to have the ability to capture real-time information, documentation, unstructured data, etc. Integrate that information in a contextual manner, right? So it's not only bringing information from different data sources, it's giving meaning to that information in the context we are working on. And that means that the contextualization, the context that I have in a refining company is going to be different than the one that I use in an upstream company and different than in a pharmaceutical company, right? So I need to define what is the domain that I'm working on and use the right ontology for that domain. And the way to, let's say, execute or put that ontology at work is called knowledge graph. That is a specific type of technology that take an ontology and operationalize that contextualization. That means that you can integrate the data with the context that is provided by the domain. So that is a base for the agents to work. Now the agents use many tools and many models. They can use models based on AI, right? Like causal AI, reinforcement learning, machine learning. They can use typical control techniques as well, and they can use tools. They can use the digital infrastructure that the company already have. For example, if I have a control system already in place, the agents can use that control system as a tool. If I have an asset management system, I can use it as a tool, etc. Right? So the implementation of the agents doesn't mean that you are going to rip and replace the infrastructure that you have. The idea is that that infrastructure is going to be part of the tools that the agents are going to use. Of course, you are going to use language models because the language model help you for once to capture the knowledge and the information about the domain you are working on, but as well help you to easily automate workflows in that context. And finally, you have a final element that is how I interact or how the system interact with the user, and that we call generative HMI. The idea is to have a user experience that allows the communication, the seamless communication from the agentic architecture to the user in natural language. And that's why we call it generative HMI. So that's a kind of a high level, very fast view of the architecture. And that translates in a system, and this is kind of a description of how we envision, right, that this is going to work. You are going to embed the knowledge in the system. This is a typical control room, right? Typical operation. And you are going to have some consoles in which the operator are looking at what is the state of the process. But you see that you have these virtual friends here. You have these agents, right? The whole idea, this is just for descriptive kind of purposes, the whole idea is that we want to put agents to work that automate some of the processes that the operator typically do, and provide insight and provide advice to that operator, and going beyond can do tasks for them, right? So now the operator is not scraping for data, is analyzing the information that the agent is providing to make better decisions, right? So what we're trying to do is a system that, take the agentic architecture to the level that the human in the loop is an additional agent in the system, right? It's embedded in the system. And the whole aim is having full autonomous operation, right? And you are going to have the human there to validate that everything is running as is, to take action if there is a deviation from normal, and to look for opportunity for improvement, right? And the agents are going to take care of the rest, right? This is in Honeywell is called Experience Cognition. This is the new generation of control system that we're working on. It's something that we are releasing to market this year, and we're working with some customer actually. We're working with a customer in the Middle East, ADNOC Borouge. Borouge is the petrochemical company from ADNOC Group. ADNOC is the Abu Dhabi National Oil Company. And they was interesting because they came to us last year and asked us the first quarter of last year. They say, well, we want to implement a system that can operate a plant operatorless. So we want the plant running completely autonomously. So are you up to the challenge? So actually they were very specific. They say, well, I'm going to give you a unit in the plant, and I want you to operate a unit in 15 days, no operator involved, right? That is a tall order. That's especially in petrochemical complexes, these are very, complicated kind of processes, right? That there are many reactions, man. There are many things that can go wrong. So what we did is we identify the critical workflows in the plant. What happens in a petrochemical plant and any industrial plant is that 70% of the time, if you have an advanced control system, the system is a steady state. The operator doesn't need to do much, right? The control system takes care of that everything runs smoothly. When there is a perturbance is where the problem is. When there is a deviation, something happen, there is a weather condition, there is a failure in one of the processes, there is where the operator needs to come in and start moving things to bring back the system to the operational envelope. So what we did is we focused in that 30%, and we went and automate the processes, that were in that 30%, and we're able to actually execute autonomous operations. So we did a first test of this approach early this year, and the results were terrific. So actually, there is a press release that we have here that ADNOC's telling the big potential that this has. We are working with them to reach the goal that they're looking for. Of course, this is the end level, right? It's running the plant without operators' involvement. We are the design of our system. We tried always to have the human in the loop. We think that the human in the loop is key to maintain safe and performing operations. But in this case, this is helping us to get to the next frontier of autonomous operations. So with this slide, what I wanted to tell you is, this is not just, a vision. It's something that we are doing, that we're executing as we speak. So this is what we have now in our portfolio. But let me tell you about the next frontier. And let's move to what is coming next. That is the moving from autonomous digital operation to physical AI, moving from digital intelligence to embodied intelligence, to make the combination between digital and physical to actually execute processes, right? And now, so we have a lot of maturity with Gen AI, with agentic AI, to automate processes. So you can look in the literature. Everybody's talking about how they are implementing agentic AI to optimize the processes, etc. But the next frontier is coming to the plant floor and start combining the intelligence that you have and the autonomy that you have with these autonomous agents into robotics and into physical execution, right? So, and these have different steps, right? The first step is, and this has been happening in manufacturing for many years, is rule-based, right? So you have robotics. If you go on YouTube and look for a plant floor, a video of a plant floor of a vehicle assembly, you can see a lot of machines like this, right? These are robotics that are based on rules. They have a sequence of tasks that they're going to do, and they're going to repeat that every time, right? This has been there for years, and this helps to do repetitive, kind of predictable tasks, right? Now we are working last 15 years, we have been working in training systems to learn, right? Using machine learning to learn what to do and to be a little bit more flexible. And there you can see the kind of robot that you find in an Amazon warehouse, for example. There are robotics that are, they have paths and they learn from all the obstacles that they have in the plant floor, and they can learn how to navigate the plant floor, right? But now we're looking for what is called context-based. Now the agent, and this looks like a gun. It's not a gun, it's a kind of a drill, right? So the idea is that now the agent that has a physical manifestation is going to be aware of the surroundings, is going to be aware of what is the situation that is happening, and is going to adapt to that based on a model that the agent has. Right? So I have a model of the world, I can analyze the data that is coming from the environment in context and make decisions based on that. Right? And that is what we're looking at right now. And the key, let's say, framework for this kind of system is what is called VLA. VLA is Visual Language Action. Right? It's the ability to capture what is coming from the environment from physical elements like cameras, like microphones, so capturing video, capturing audio, capturing text, etc. Sensors, the vision is, when we call vision, is a broad term. The idea is to capture anything that is happening in the environment. Then translate that into language to understand what is happening, and then translate to action. So that is the idea. So unlike traditional software, here is first is multimodal, right? It's not only text, it's images, video, audio, etc. And the idea is to understand the context and then go and execute. And one key factor for this VLA, model to work is something that we have been working for a long time now in the industry as well. That is the digital twin. How the system can create that model that allows to think and to react or to take action when something happens. That is done via simulation, right? So you create a model of your process, you simulate the process, and then you can train your agent in different kind of situations. It's like what is happening with the self-driving cars. So I don't know if that in Arlington you can see the Waymo, but certainly here in Houston and in Austin and some other cities, San Francisco, etc., you go out and you see driverless taxis everywhere, right? You see all these guys driving in the street. That was unthinkable 10 years ago. Now it's a common, is part of the landscape. And how this driverless car can go around, without a driver and, don't crash, roll over people, make mistake, etc. It's because they have been trained in a simulated environment with data that is coming from history. And that is what we do in the industry. We create models, and with those models, you can train the system and you can simulate different situations, different scenarios, so that the system can be ready to react when that happens. And that gives the flexibility to the model to act like the human does. One element that is important in the physical AI is the ability to have reasoning, computing capacity at the edge, right? Because usually when you talk about Gen AI, agentic AI, etc., what you do is you take data, you move that data to the cloud, you have a large computing capacity that is elastic, and you can process all that data in the cloud and then bring back the response. But when you are in the plant floor or you are in a car, the example that we have in the slide, you need the processing of the data right there, right? In the plant floor or in the car. You cannot go to the cloud and back. And there is where you have what we call edge computing, right? You see there are some developments, especially NVIDIA is working in what they call NPUs, that is edge computing, that put chips at the edge level so they can process the information that is happening in the plant floor or in the car or wherever the edge is set, and take the action immediately without going to the cloud. So the whole let's say the whole paradigm is you train in the cloud because you have more capacity, more elasticity to do, and you do inference, you execute in the edge. If you go and do some research and analyze why AMD, the chips maker, is making great in the stock market, is because they didn't focus in training like NVIDIA does. So NVIDIA focus in GPUs and training, etc., in the chips that are in the data centers. AMD, instead, they focus in the inference. They focus in the chips that are going to be set in the cars, in the robots, or in the smartphones that are going to be are going to enable to do the processing right there in the field and make decisions right there in the field. So so you have this combination of training in the cloud and inference and execution in the edge. And this is key for physical AI to be a reality, right? You need to have that level of processing capacity. And that enables what is called the autonomy flywheel. That is an endless cycle in which you are collecting data, you are comparing the data against a model that can have different shape and forms. You train or retrain or reinforce the training of that model. We deploy the inference in the edge and execute, and then learn from it. Remember how we started? We started with see, think, act, and learn. It's the same thing, right? It's an endless cycle in which you are capturing data, modeling, executing, and learning from it, right? And that is going to go, and every time that an action is taken, every time that I capture information from the environment, my system is getting more robust, or it is getting trained, right? Now, there are barriers, right? Some barriers, for example, the models are not perfect. The models are far from what the reality is. So one of the challenges is how I can reduce the gap between the simulation model and the reality, and how I can make those models better. Then how I can trust the system, right? And what are the guardrails that I need to have in the system so I make sure that it's working as expected. And then that this system, these agents and these physical AI components need to work with whatever is there already in the digital infrastructure. So how I make sure that our system, our agents are gathering the data from all the data sources that are required and are executing actions via digital infrastructure that is already in place. How I can guarantee that interoperability. And this is the challenges that keep us busy in companies like Honeywell, right? We're trying to solve all these challenges for our customers. So what are the imperatives for leaders? First, you need to get governance of this kind of system. You need to have guardrails. You need to comply with regulations and policies to make sure that this is working safely and is working according to those policies. Then you need to invest in data infrastructure. Again, both are at the training level, the cloud, and at the edge. And then you need to prepare your workforce. The workforce now needs to understand that it needs to start working collaboratively with agents that are digital, agents that are physical. It's part of the reality, and it's a new way to approach how the processes are managed. So that requires change management, and it's a very important factor. And now, well, we can see that we are moving from agentic AI, that is what is on the top right now. There is a lot of implementation on that thing. And now for the future, we're talking about biohybrid, right? So having robots that are more than aluminum or metal and going to use some sort of tissue, living tissue, to give more flexibility. This is futuristic, but there are tests already in motion using quantum computing at the edge to do better inferences. That is also maturing, something that we're looking that is coming in the future. But the reality is that now the investment is in taking this resonant capacity from the digital world to the physical world, and how we can make happen that in a performing and safe mode. So final message, the convergence is here. The physical AI is a reality. It's not something that is a science fiction. It's something that we're working on right now. And the era of the AI factory has begun. AI is no longer kind of an anecdotic, kind of futuristic thing. It's something that is part of the reality for any industry right now, and we need to be prepared for it. Okay. With that, thank you very much. And I don't know if we have some time for some question and answer, Franklin.
Yes, of course. Thank you very much, Cesar. Really, really interesting what you mentioned. I think it's great. What is going to be, what's happening now, what is a little bit in the future about that. So really, really wonderful. Guys, do you have any questions? So far, maybe would like just to ask you something, Cesar, about your experience. How is taking the industry, the use of artificial intelligence, because are they really open to it? Because there are so many people who are a lot of concern with it about security, cybersecurity, about the data, how it's going to be just safe and all these kind of things. So there are even some kind of companies that now they're having the policies that they are not using any kind of, more in the case of generative AI and all these kind of new artificial intelligence implementations, because they are not so sure about how to handle these kind of things. According to your experience, what have you found in these cases? Are really companies open to this? They are a little bit, I don't know, accepting about this. What have you found in these cases?
Of course, you have different segments of companies, right? That there are some that are more open than other, but in general, the gains that are realized so far from AI implementation are so great that most of the companies, if not all, are looking for the way to implement some sort of AI solutions in their processes. Of course, when you talk about process operations, when you go to the industrial floor, there are more guardrails that you need to take, right? And there are more, if not skepticism, is more, let's say, care, more cautiousness from the industry to implement solutions. But we are looking at many customers asking for ways to implement AI and way to automate workflows and implement agentic AI. So it's starting to be part of the landscape. Many of our customers, some way or another, are implementing this kind of solutions, and is moving from being kind of anecdotic, kind of use case here or pilot here, pilot there, to be something that is part of the digital infrastructure, and that is across the board. You have companies in the Middle East, for example, that want to go all the way to full autonomy. And they are kind of the leading the way in the innovation in that front. Or in the North Sea, you have some companies that are really investing in this kind of technologies. You have some other here in the US that are more cost driven, are more focused in how I can be more efficient. But all of them are looking for gains from AI, and we're looking a lot of adoption there.
Here is a message from Emily. Okay, thank you, Cesar, joining late, but the presentation was very interesting. Thank you so much for it. Any other question, guys? You want to ask anything to Cesar? You already have there his mail. Want to ask it?
Yeah, if you want to connect with me, of course, please send me a mail, and I'm more than happy to interact with you guys and to provide any information I can.
Maybe I don't know if you have your LinkedIn, Cesar. You can maybe share with in the chat. So maybe let me try to find it.
I'll do that.
Maybe usually that could be also a good idea for people to try to find you. If you don't have it, I can get your LinkedIn and I can share it. You have in there?
Let me look for it and paste it in the chat. I'm more than happy to do it.
I found it. So
there you go.
I have. Yeah, there you are. You have there in the chat, Cesar LinkedIn. So maybe you can also keep in touch with him with this information. And so certainly, well, thanks a lot, Cesar. It was really, really a pleasure, as always, hearing the kind of wonderful thing that you are doing nowadays. And well, it's also a pleasure for all of us having you. And well, we hope that we can also have other opportunities and that you can come to our campus on.
Yeah, I need to do that, definitely.
It would be great.
More than happy to do it. And thank you very much for the space, Franklin. It's always a pleasure.
Thank you so much, Cesar. Take care. Well, say hello to your family. Bye-bye, Cesar. See you.
Have a good day, guys. Bye.
Bye-bye, guys. In your recording, here is already connected, our second guest. Hello, it's really a pleasure also for me introducing today our second very invited guest, that is Dr. Begoña Garcia. She is joining us from Spain now, from Bilbao in Spain. By the way, it's night there, so really appreciate a lot that you are connecting from there, Begoña. It's always a pleasure. By the way, Begoña is a really, really well-recognized researcher all around the world. She has a lot of research in the area. She works in the Deusto University in Bilbao, Spain. She's leading a lot of great different projects. One of the tops that is the part of the future of it, that is even the use of quantum artificial intelligence. Some of the people in Begoña's team are working with it and with very important applications in the area of health activity. So that's amazing. Just to give you an idea, usually when you are a researcher and you try just to publish or to try to make your papers and things like that, usually you can see how well are you doing your things, because when people are going to be just referencing your works and sitting there, because that tells that your works is trying to give some inspiration to other ones to make some new researcher. And well, according to this level, Begoña has a very high, so she's in the top of other researchers in this area with more than 11 different citations of her works. And so that means that is really something amazing. By the way, she's a very kind lady also, and well, open to all kind of cooperation relationships. And so really, I'm very happy having you here today, Begoña. It's always a pleasure. And thanks a lot for being at this time today with us. Thank you so much.
Hi, everyone. That's a pleasure for me to share this moment. I really appreciate when Dr. Rivas invite me for this kind of talks to you guys, because I really enjoy sharing with you and discussing with you also how technology can help to improve the situation and the status of health and well-being in general. Most of the countries, we share the same problems, and then we could maybe share to the same solutions, right? So that's that is going to be the main point of our talk today. We're going to talk about one potential solution, that is the use of a paradigm Health 4.0 as a methodology to create, let's say, holistic approaches using technology to solve health-related problems. Okay, so let's get started. So I'm talking to you from Spain, from the north of Spain, the border with France. I'm not sure if you are familiar with this area, but yeah, here is almost 15 to 8 p.m. And I'm gonna share with you my screen. And several examples I will give you are examples of different projects we are developing in Europe. But my collaboration with the US is very close. We have been working together with different universities in the US for many years, and now we have also starting some years ago the collaboration with your professor, Dr. Rivas, and that's a pleasure always to collaborate with him. So let's get started then with okay, with the summary, the index of the talk today, a brief introduction about what are we doing, who are we, right? Then let's go directly to the topic. Let's go to the point of what Health 4.0 approach is, with different health case studies, directly with Health 4.0, and then in particular with the importance of healthcare data, and with some case studies where the use of computer games has been successful as a technological solution for especially elderly people, children, also for regular adults, of course. But these two populations are really very well receiving very well this kind of contribution based on computer games. Okay, so as an introduction, this is our university in Bilbao. We're in the north, as I told you already at the beginning of my talk, and this is the university, so it's very green. Green means that it rains. So sometimes it's good, we have nice weather. Sometimes it's green, that means it rains, and we suffer of rain. Not like in the US, not such a big storm, but we have our tiny storms too. Our university is a very old one. It's from 1888, so it's quite old. That's why the building is old-fashioned, but it's because it was built at that time. And then those are the main research fields where we are working on. On the left side, we see signal monitoring. So, of course, we use sensors to try to monitor signals. There are so many sensors in the market right now. The issue with the sensors is sometimes the values they are providing, or when you acquire different data from them, they are not always accurate, but okay, we still use them. And we have used that in different projects, especially in cardiology, in psychiatry, to monitor and prevent ischemic cardiac seizures. In psychiatry, for early detection of schizophrenia seizures too, and sarcopenia, and oncology to monitor the evolution of the patients, right? Then we have the field of medical image processing. So that's, when we talk about processing, nowadays, not in my time when I studied engineering, processing was the main role of an engineer at that time, developing, programming in MATLAB algorithms to extract from the image features that could help the doctor. Now the processing is just the preparation to the image to be to use as input of an AI model, right? So things have changed a lot, and with a good purpose, and with good results also in medical field, right? Wow. And then artificial intelligence, big data, we'll talk a lot today about that, and special interest. We had a special interest on the brain. It is amazing how our brain works, and how can we define experiments, and there are such a important difference between the connections of every person brain when you prepare an experiment, or put in a movie, or provoking a certain emotional moment. Every brain works different, and that's amazing to analyze that. And then, from the point of view of how we survive doing research in Spain, and especially in this region, which is called the Basque Country, we have a lot of support from our government in terms of innovation, not so much research, but innovation. So they want to provide with research development to the companies in order to improve the products and services. So we do have a lot of help for that transfer learning from the university to the company. So it's most of the products are related to well-being, not so close to the health really area as the product, but as the product is more close to the well-being, to the daily life, how to develop, services for mobile devices, rehabilitation, robots, development for robots, or computer games for health, right? So this is what we have been doing for the last 25 years. And if we look at the model in the US, there are not so many differences between Europe and the US in terms of technology, but the main difference is how we call it, right? In the US, you call it smart and connected health. And in fact, your big national science foundation, the NSF and NIH, the National Institute of Health, both of them work together under these with the main objective of using sensor technology, networking, modeling, machine learning, ITs, and DSS, so decision support systems, to provide healthcare facilities and connect devices with wearables and have help monitoring our lives, right? To help us, not as a control, but to help us, right? So this is how in the US you call this research area smart and connected health, but in Europe we use more the paradigm linked to the industry, right? Industry 1.0, we call it the mechanical industry. Then the 2.0 is the electrical, when companies had electricity, industry had electricity, and then electronics arrived, and then it was called Industry 3.0. Then now, when we have all this, and we have also sensors and artificial intelligence, IoT, cybersecurity, when we have all this, we call it Industry 4.0, right? And if we merge this concept of 4.0 with the medicine evolution, which is summarized in this graph here, where until, let's say, 2010, the medicine was more curative. In 2015 was more prevention or early detection. And then now we definitely are focused on prediction and personalization. This medicine is called 4P medicine because it's preventive, predictive, personalized, and participative. And all this combined together brings us the paradigm Health 4.0. That means that every time one client shares with us a need, have this problem in healthcare sector, then we need to consider at least the 8 technological areas that appear in this graph, right, in this image. So, for instance, they share with us a problem, and then we say, okay, let's focus on autonomous robots. Do autonomous robots help? Would autonomous robots help to have an appropriate solution for this problem? If yes, okay, we will include it. If no, okay, we will not. Let's consider now AI. Would AI help to have a perfect product to solve the problem? And then we analyze if AI would help or not, and then we decide if it is in or out. Signal processing, of course, if we have signals, then we need to process them, at least filter them, removing noise, and so on. So in both one dimension, which is the heart, for instance, electrocardiograms or the electroencephalograms, there are one-dimension signals, or 2D, which is images, or 3D, our brain, when you have, the 3D of our brain. All these together, algorithms, if they help, we will include them. Of course, Internet of Medical Things, so sensors with the embedded system, Raspberry Pi or Arduino, to make the data acquisition from sensors. Okay, if it makes sense, we will include it. If not. So all those 8 areas, including also augmented reality, virtual reality, it's very helpful. Sometimes for training, doctors, they have some training based on virtual reality. Okay, and in fact, our students in biomedical engineering degree, with I am the director of the program on biomedical engineering, we train them using also virtual reality to go with the cells, the life of the cells and the molecules and how the blood, the path of the blood, and all these they learn using virtual reality. Of course, additive manufacturing is also a key when you want to develop a prototype, because additive manufacturing allows using different sources of materials to create products. And of course, cybersecurity and cloud computing, of course, these almost all the products linked to medical field will have those areas, right? So if we compare the paradigm 4.0 in Europe and on the left side, the US one, in fact, technologies are very similar. It's just more the methodology of, okay, for 4.0 approach means you consider really all those areas to create a product, let's say, fashionable, only if the technologies help, of course. We don't need to put 8 technologies together just because 4.0 has these 8 technologies, but just consider if the product would be better or not using those technologies, right? So, I mean, in terms of technology, is similar, just a methodology would be different, right? And robots in healthcare, we have a lot of different type of robots in healthcare. Some of them are help during surgery. Some other help like assistive robots. We have in the lab a couple of robots, nice ones that with their face have 2 cameras. In fact, they analyze the person, they interact with the person, they can help if they have a problem at home. So robots are very helpful, but those robots have also sensors on them and they acquire data and they use AI. So robots themselves, they are 4.0, in fact, right? As I said, virtual reality and augmented reality is fashionable and is helpful. It is not fully developed in our hospitals, at least in Europe. It's more about research and about movies, but it's not fully developed. But it's true that there are, several fields where some surgeries include this augmented reality, which means add real data from the real world to virtual images, right? Then Internet of Things, which is Internet of Medical Things, other very important block too. We have so many sensors around us, right? We can control ourselves, our healthcare. We can control environmental health, measure, for instance, temperature, humidity, air pollution, right? With the different particles, PM 2.5, PM 5, PM 10. So sensors are everywhere and they help. And now most of the cities have open data related to, for instance, air pollution. So AI can have access to open data related to this kind of information and develop different systems, right? So look, there are even articles that use Health 4.0. This is from 2019. So, it's not just this year that we have started working on this approach. There are already publications that use this Health 4.0 approach. Look at this one too, from Springer. Look at this one also from Elsevier, Industry 4.0, and Health, right? So this in 2020. So it's something that is nice. That's why Professor Rivas wanted me to share with you this paradigm, because maybe you were not familiar, and that was the purpose of this talk, right? So some examples of some research we've done. In fact, we try always to include this 4.0 paradigm. For instance, this is an example of a Health 4.0 applied to multiple sclerosis patients. The idea of I usually call it technological solution, right? So the idea of this technological solution is offering the doctor the ability to reach the patient through a digital platform, of course, and the patient to be able to develop different rehabilitation programs in terms of logopedia, physical rehabilitation, and providing them with this kind of glove that is a smart glove, has inside kind of different motors, kind of a mini robot, a lot of sensors, and people with multiple sclerosis have their hands something like kind of blocked, and it is very important to make rehabilitation of their hands. And sometimes they don't have the possibility to go every day to a rehabilitation center. In fact, in Spain, we have public healthcare, so it's free for everyone, but we have usually once per week service at the hospital for rehabilitation. So not every day, you can have once a day, right? So once a week. So the solution is to develop something, the patients can go home and they can digitally access to some rehabilitation services, and using this kind of personalized gloves, develop those exercises the 7 days a week, even if just one will be at the hospital, right? So a lot of sensors. So we had Internet of Medical Things, we had a lot of signal processing to measure if they were moving, if the angle of movement is bigger or not, is improving. AI to personalize exercises, a little robot on the glove with some motors. This, we didn't include anything about augmented reality in this case. And additive manufacturing, yes, this red color was printed in a 3D printer and all the data were in the cloud. So we just included most of the areas, not all of them. We don't need to include all of them. We just need to consider if the product would improve with them, right? Another example of 4.0 is a project we developed with the US, with the University of Louisville. In fact, we did a patent. We had a US patent together that we shared. The purpose was to help doctors to measure the evolution of pressure injuries with kind of wounds that appear all over, all around the body. And the wounds, the problem is that skin is open, and then that means that bacteria can enter, and then 20-something% of the patients die, in fact, due to a bacteria infection, right? So the doctors were sharing with us the problem. Okay, we have people that are dying. How can you help us without touching the ulcer? Because I mean, they have a lot of pain, right? It's very painful. This is, the skin is open. This is really, very painful. We cannot touch there. So what we try is to develop a product where using AI, using signal processing, using Internet of Medical Things, because we included a lot of sensors, of course, cybersecurity and cloud computing, this almost always, and then additive manufacturing, because we created a prototype. The idea is with this, we can go to the patient, acquire information without touching, so non-intrusive, and then monitor the evolution and the risk of bacteria infection. So this was the prototype, super ugly. We are not very stylish developing prototypes, but this was the prototype with different sensors, acquiring information with this screen where all of quantitative data were recorded and sent to the cloud, and then AI was able to make its job and personalize the prediction about, especially if the patient had a risk of death. That was one of the things. Look, to develop that, we struggle with the number of images. When we work with data, sometimes data is not big data. Sometimes data is just, small data, in fact. So we were struggling with images. We had all those images acquired one by one in our hospital. Myself was going to the hospital to acquire the images after the ethical committee. But in the US, what they had was Kindred Healthcare, was a company that was very interested in this topic, because they had a lot of patients with this problem in the US. And they said, okay, we cannot provide you with images for the testing phase of the AI, and then you show the images of the testing phase. We cannot, but we were able to do that in Spain, but not in the US. So, okay, let's take the best of both of us. And then the training was made with the US images, but the testing was made with the Spanish images. In fact, we mixed a little bit the Spanish also during the training. And then all the publications were using Spanish images that were allowed because the patient signed, informed consent and all this. But the training was made with 4,000 something more images. So we had 278 for the testing and 4,000 for the training. So we had, almost 5,000 images for the study, so the models were predicting pretty well. Okay, so more cases about data. Okay, data is so important. I mean, I've been working so many years on this, and the big challenge is always to get cleaned and curated data for the purpose we wanna work on, right? Or the disease we want to predict, or so this big data in healthcare very often is a dream. And we found data, some of them structured, but others is unstructured. The quality of the data is not always the best, and we have noise. And with this, we can create confusion to the AI, right? So data is the key of success when we want to implement Health 4.0 or just an AI model, right? Another challenge is how to transfer from universities our models to the real practice at the hospitals. And in Europe, we are super bad on this. Believe me, I mean, our publications on AI with very, pretty well models predicting things such important as, for instance, an amputation of a leg to a person that has diabetes. This happens. People with diabetes has this risk, and come on, it is a big complication. So, so if we were able to transfer that to our hospitals fast, we would have a much better service. And in the US, you are, excellent on that. Look at this piece of newspaper. Look at the year. Can any one of you tell me what is the year of this publication? The year? Can you see the year there? You can connect the audio. I see you are writing in the chat. Let me see. 2014, exactly. 2014, I mean, more than 10 years already. And in Mayo Clinic in Rochester, they were using already big data models to their services, right? I know they are private, they are super expensive, they can do that. But I mean, it is not always easy really to make this transfer. So congratulations, in fact, to the US for this ability of fast transfer of knowledge to companies, and in this case, hospitals, right? Okay, so additionally, sometimes we were working with 800 patients records that were from Mexico. In Spain, we got the same approach of ischemic disease from the heart. We had 5,000. That's not bad. 1,000. Diabetes, we were very lucky. We were able to have access to all the diabetes patients in our region, the Basque Country. And I was very happy having so many patients, but I was surprised at the same time that we had 150,000 patients, a lot of people with diabetes, and there are very acute complications. One was the one I have mentioned to you already, so amputations, right? So the big deal here was the cleaning. Remember, we had 150,000, and in fact, we ended up after the cleaning getting just 47,000. So we lost a lot. We just kept 1/3 of the initial data. And then, okay, this is something that happens very often in our field. So we need to be prepared, okay? We've worked also with breast cancer. That was amazing. We didn't have so many images neither. Look at the numbers, right? But the super nice thing an interesting thing here was that we had a lot of images from breast cancer. So there was a cancer on it, and we were detecting the cancer within segmentation and classification. But the nice thing here was that we were able to work with a hospital. It was a Mississippi hospital or something like this. I was collaborating with the University of Louisville too at this Mississippi hospital. And then they had, look at this, they had images from patients, mammographies from women that were healthy. And then mammographies for people, imagine myself, I have my mammography healthy, next year healthy, next year healthy, and then next year is malignant. I have something that is unhealthy, right? Malignant. Okay, we were able to predict that with my healthy image, I had the risk of have in some years malignant. So that was a big, big, big contribution. And just we were using at that time YOLO for AI. So it wasn't a super innovative and disruptive model. It was with YOLO. But with those images where the doctor was telling is healthy, the system was able to learn that something there was not so healthy, and probably in some years there will be this risk of have breast cancer. So some of the research is grateful for us, right? And then the other opportunity to use AI with in medical field is about the text reports from doctor and use NLP for text. Myself, it is not my favorite topic, the use of NLP. I prefer images and fusion of multimodal data, but also, of course, reports was text is important. We were working with text during COVID-19, and we were using for early detection using text of anxiety and mental health problems. At that time, remember, it was a very difficult time for everyone, right? And finally, the last, let me check the time. Okay, I think I'm fine. The last topic I want to share with you is about computer games, the power of computer games. Let me share a video. Hopefully, I will stop sharing. Before the video, is anyone interested in some clarifications or something? Let me see. I think I saw in the chat some questions. You can feel free to connect your audio and participate, okay? I'm really interested in the early detection of illnesses developing medical. Yeah. Enzo, are you there?
You
Yes.
can open the mic.
We can-
Okay. Thank you.
Yes. So can you explain more your question?
Oh, yeah. You mean like the first question that I
Yeah,
received?
you've been very active with questions. I see, very good.
Okay, yeah.
You
So,
have
so sorry.
suggestions. Yeah, no, it's excellent. I really enjoy people in the US is much more participative on the talks. Spanish, we are more shy for that. So I really enjoy talks where students talk and share. So yeah, just go ahead. You can just explain
So,
talking.
by the way, I speak Spanish as well, but
Oh, excellent. But
yeah.
yeah, I think for some it will be,
But
yeah.
just to share like the question with everybody, I wanna keep
Yeah,
talking
yeah.
in English. But
Excellent.
well, first of all, again, like thank you for your time. Like this is like really good information. And also, I was talking with Dr. Rivas about some opportunities, to do some research on medical staff, because again, like I'm interested on working with machine learning, AI, those technologies, but related to the medicine staff. I'm still learning. I'm still like trying to, get that knowledge, and I'm trying to also, actually this meeting is too helpful for me, because actually I couldn't attend the last one because I was in class, but now this one was the one that I was looking for. But regarding to my question, basically, I was saying, like, so how do you detect, those injuries in the skin of the people? Like, are you using like image processing, or like what is like the method in order to recollect, the important information in order to detect that illness,
Okay.
like necrosis and all that stuff?
Yes. For the study, we just used a tablet. We could have been using a mobile, but the hospital rules were like this. They didn't want mobiles because then, images could be sent by WhatsApp or something on Social Security, we were just allowed to use tablets. And nurses and myself, I was going there to take images because they were very slow. And then I was there every time calling, "Do you have a patient with a loss?" Yes, yeah. I was running to the hospital and it was to acquire images because we needed images. And then we were just using a tablet. Yeah. So the thing is that to have an accurate segmentation of the image and then accurate and preprocessing is a key. I have mentioned, 1 dimension, 2 and 3 dimensions signal processing is still key to have a good result on AI, but just key to prepare images. Then the AI makes the rest of the job of segmenting the region of interest, and then measuring also some parameters on it that can classify the tissue as necrotic. Which, if it is necrotic, they just were, cleaning with cutting pieces of it was a little bit painful for the patients, in fact, but they were like cutting this necrotic area. If there was a bacteria, and sometimes we detected bacteria, they needed to put antibiotics, strong ones. If there is a slug, which is another type of tissue with slug, this means that there is a risk, but there are no bacteria yet there, so it wasn't bad. And the red one was very good. That means that muscle, because there are muscles that were recovering, and then skin could start closing the ulcer, right? So just a tablet and models, AI models, and we did a patent in the US. It took us 5 years, or almost 5 years. It was like it wasn't the best period in my life in terms of patient. I needed to be really patient, and I am not a person that with patience. So it was, I cannot believe so many goes and back with the lawyers, but it was published, it was accepted, but you know what? By the time we got accepted, of course, models were not updated at all, and we needed to restart with new models. But okay, that's fine. That's fine. We need to be creative in engineering.
And so, what are the technologies that like people is using in order to do those type of image processing or signal processing? Because in my case, for example, I was told that Python basically is like the main language actually that is used, behind the scenes in order to work with or create like systems with AI plus, machine learning or deep learning, whatever. But like to create the algorithms in order to process the image. Is it correct? Like, is Python, or is like what technology do you have in mind that easily can tell me?
Yes, we use Python for AI, no doubt. Python. It's what we use it, right? But for image processing, we use MATLAB. We love MATLAB. It's still very good, and
Really?
yes,
Wow.
yes. So it works very well. But so but in my time we use MATLAB for everything. So there are a lot of toolboxes that are very helpful, right? So but you can use also Python, of course. What I don't like really is R. We can do that things in R, but I prefer MATLAB, Python, or only Python if you want, but not R or other tools. People that work more in statistics, they prefer R, and they can develop AI in R, of course. Yeah. But not in our case. We use just MATLAB and Python. Yeah, that's the two things.
Yeah, I was using, I remember like my first image processing was, when I was using MATLAB. But I was talking with a professor in my community college when I was attending on there, and he was saying, well, like MATLAB is good. The thing is like the libraries are better in Python, so basically you want to actually work with Python. But again, like I'm not like an expert on MATLAB, but it seems like it's an old language, an old technology basically.
Yeah,
Um,
update it all the time. I mean, they update it all the time. So, but you need to pay a license. So many people don't use MATLAB because of the money. It's quite expensive. But
yeah,
we
right.
have that for free at the university. So So yeah, we use them. But I mean, toolboxes are very good now. They have improved really. I mean, they have a lot of things on AI with AI also. But with the AI, it's like a black box. It's not so easy to touch. And Python, you can really manage very well all the layers. And so for AI, I definitely prefer Python. But yeah, if you have a license in the last version of MATLAB, try it. It goes very well.
I will for sure. I will. So actually, you asked the last question that you made was in which area are we like are we interested? So in my case, I'm really interested on something that works related with brain illnesses. You know, I have like a personal I don't know how to say, like a personal experience, let's say. So my grandma, she basically she got one illness, which is dementia. And one of my interests was, okay, like try to work, you know, in those type of projects to understand, you know, how it works and eventually try to help people in the future with those type of, you know, to solve those issues that we as humans, we didn't yet solve. So basically, what projects are you making, or I don't know what uh, interesting project are you creating now, or like are you or I don't know, or which project did you already have, you know, in the past that you say like it is really interested, or like you know something related to
The
brain,
brain to the brain, yeah.
yeah.
So with the brain, we had a study about the differences on brains with children with dyslexia. It was a control group, so no dyslexia, no nothing. Another group with dyslexia, another with visual impairment. So in particular, it was a monocular vision. That means that they don't see 3D. And then we had these three groups, and we were studying how we're directing to an experiment, right? We were preparing some words, real words, pseudo words. So instead of table, we were writing whatever, power, whatever. I mean, no, it wasn't the word, it was a pseudo word. And so we had a full experiment, and we were doing that in a machine with a functional magnetic resonance machine. So you were on the machine, and then the machine was showing you things, and we were recording what was happening on their brain. It was amazing to verify how differences every brain, and that all children with dyslexia were reacting were developing this compensation paths. It's called like this, compensation paths. So their brain were searching solution to get into the something, and then control group was what the state of the art was telling. So reaction was a molecular vision. They had totally different reaction to dyslexia. There was a hypothesis that people with monocular vision means they have two eyes, but they just don't see 3D. The two eyes don't combine together to create 3D, right? That is the problem. So they have two eyes. You don't know if one person has a monocular vision, but if you put the glasses, 3D glasses, and they don't see 3D, okay, they have monocular vision, right? And then their path was totally different to one with dyslexia. And the hypothesis of some doctors was no, it is the same. The same compensation path will follow children that have dyslexia and others that have monocular vision. And it wasn't true. We published the study, in fact, and it was totally different pathways and behaviors, right? Then also we did a study with people with migraine. Some people with migraine they call drug abuse. That means that they have so much pain all the time that they feel they have pain and they have pain and they have pain and they take drugs and drugs just to avoid having pain, right? And they were analyzing what was happening on their brains in order to feel that, right? And it was also an interesting case with the neurologist to analyze what was happening with those patients. The thing is that in those type of studies, we can understand what happened on their brains, but we cannot create something that'll solve the problem. That's the first frustrating, but it's what it is. And then now we are working with stroke. Stroke. Stroke is increasing a lot in people 50 plus. Supposedly, stress is one of the causes of this increase of stroke. And it is a real problem because if you don't take the stroke on time, you can really, have very acute complications. And then we are studying the cognitive impairment coming after stroke and how could be the monitoring. So yeah, brain is amazing. I love brain. The thing is how to get data from the brain is not so easy, but yeah.
Yes, actually, I was talking I guess the last week with Dr. Rivas because I'm actually interested on that, but I guess in some way I need to learn a little bit of medicine. So like
Yeah.
at some point, right? Because it's like I guess it's like a lot of things to learn, in order to understand like how the brains work. I'm also interested in some kind of applications of AI in vision stuff. My sister, she's a manager in eye clinic. So basically, like every time she tell me, different stories about, patients with issues. And actually, my mom, she has like a trauma, which basically she needed to have like a cleaning of the I don't know how is it called, like the I'm gonna tell you in Spanish. I don't know if you know the translation, but la retina, which is like
Yeah.
the eye. So the thing is like all those prostheses, they are like managed by a machine, during the surgery, and then it just track that you are not like surpassing or like not putting that in the correct place. And that was like something interesting to me. Again, like I don't know anything about the
Enzo, there
technology
are
behind
so
that.
many. I'm sure every time, every person in the room now, in the virtual room, has like has something that because of your family or friend or something close had new ideas to improve, and there are so many room for improvement. And with Dr. Rivas, we have a close collaboration. He visits us. We invite him for our PhD dissertations. We share students on thesis. We can receive his students here to do some internships. So please feel free to talk with him, and he's a great facilitator, and then we can together. If you are interested in doing things, and you can do that there, or even come in here. So yeah, I'm sure Dr. Rivas can manage this very well. And I see the time, so I don't
Yes.
want to extend myself because you have
Yeah.
your. So you miss the computer games part. I will tell you that next year.
Well, my dear, well, thank you very much, Begoña. Really a pleasure. Quite interesting thing you mention all the time. By the way, I think today was a great things because we could see something that we always talk about that in our class, that is about the legal part of it. Because you mentioned the typical problem, you need always to focus on the legal framework of each of the different countries you're working with. So when you're going to be talking about in this project that you have with the United States, with Spain, different places, you need to take care of the laws and what are the acts that they have in each of the countries. And that's wonderful because that's the idea, to try to use this. And that always we talk about that in our classes. So I think it was amazing to know about that. And again, as was mentioned by Dr. Begoña, it's open any kind of cooperations in here. So I think it will be wonderful continue cooperating with Begoña and her team. And well, of course, it was really a pleasure having was such an amazing person today with our class. Thank you very much, Begoña. I know it's very late for you also. We appreciate a lot that you take your time for being with us. And well, I hope keeping in touch soon. All right.
Okay.
Well,
Thank you
guys.
so much for everyone.
All right, guys, take care. See you next week in the class. And thank you very much for your attention. Bye-bye. Take care.
Bye bye. Bye bye.
Thank you. Thank you.